Let's solve Unit 1 Discrete Structures and Optimization questions. Which of the following graph is or are planar? What is actually a planar graph? A graph is called planar if it can be drawn in the plane without any edges crossing. If you take all the three graphs, you have edges crossing one or the other way. If you are able to represent the same graph without any edges crossing, then that can be called as planar graph. What about A? A can be drawn in this way. So which edge is crossing? C and D is crossing. Instead of going in the midway, what we can do is we can go in a roundabout way. Here we are not worried about what kind of representation it is. We have to make sure that the edges are existing as it is. A, B edge is there, B, D edge is there, A, C edge is there, C, F edge is there. Similarly, D, E, E, F edges are there. B, F edges are connected in between and we are connecting C, D edge in roundabout way. You can represent it in this way. Otherwise, you can have A here, B, D, E, F, C here. C, D can be connected this way and B, F can be connected this way. Either way you can represent it. So definitely A is planar here. What about B? Now this will be the planar representation of B graph. So let's check whether all the edges are present. From A we have C, D, E, F. 4 edges are there from A. So from A we will check, we have C, D, E, F. 4 edges are there. So A is done. What about B? From B we are connecting to C, D and F. So from B to C, D and F. 3 edges are there. What about C? From C we are connecting to A, B, E. 3 edges are there. So from C it is A, B, E. 3 edges are there. What about D? We are connecting to A, B, F. 3 edges again. So A, B, F. 3 edges are there in D. From D. What about E? From E we are connecting to A, to F, to C. 3 edges again. So A, F, C. 3 edges are there. What about F finally? A, B, D, E. So A, B, D, E. So all the edges are represented here in another representation. So this is definitely a planar graph. One clue from the options is at a time only one graph or two graph can be planar. Since we know A and B are already planar, we need not check with C at all. We can go with option 4 as the right answer. Next question. The probability that A hits a target is 1 by 4 and the probability that B hits the target is 2 by 5. Both shoot at the target. What is the probability that at least one of them hits the target? That is that A or B or both hit the target. What is probability of A? It is the probability that A hits the target. So this will be 1 by 4. What about probability of B? It is B hitting the target, which is 2 by 5. Now what they have asked us to find is what is the probability that at least one of them hits the target. When they say at least one, it can be A singly, B singly or both A and B. Any condition can occur. So we are going with the formula P of A union B, which is equal to P of A plus P of B minus P of A intersection B. In this formula, you have to find A union B, that is the question. We know the value of P of A and P of B. What about P of A intersection B? P of A intersection B is the probability that both A and B hit the target. Since they are independent, we can multiply both the probabilities. So P of A intersection B can be calculated as what is P of A? It is 1 by 4. What is P of B? It is 2 by 5. We can cancel 2 here. Altogether you will have 1 by 2 into 5 is 10. So P of A intersection B will be 1 by 10. Now we have the value of all these three. So we can go for P of A union B. P of A is 1 by 4. plus P of B is 2 by 5 minus P of A intersection B will be 1 by 10. When you take LCM, it will be 20. 4 into 5 will be 20. 5 into 4 is 20. So when you multiply by 4 in the numerator, 2 into 4 will give you 8. Then 10 into 2 is 20. So we will have minus 2 here. What is 5 plus 8? It is 13. 13 minus 2 is 11. So 11 by 20 will be the answer. Option number 4 will be the right answer. Next question. If x and y are elements in a group G and if x power 5 is equal to y power 3 which is equal to E is the identity element of G, then the inverse of x square into y into x power 4 into y square must be which of the following option? Let's denote the element by z is equal to x square y x power 4 y square. The inverse of z is an element that when multiplied with z gives the identity element E. When you multiply z with z inverse, you should get E here ultimately. That should give the identity element. Z inverse can be found by taking the inverse of the complete expression. When you apply inverse to these elements, you should go in the reverse order. We have to start with y square. So y square will apply this inverse individually. Then we go with x power 4. This will be applied inverse now. Then y inverse. Then x square inverse. This is how you have to apply z inverse to individual elements here. Now we have to find the inverse of the individual elements. Basically, we are having the inverse for all the elements together. Once we applied inverse inside the parenthesis, we are making it as individual elements. When you have y square inverse, you have to just swap the powers here. Y inverse of power 2. So x power 4 inverse will be x inverse power 4. What about y inverse? This will be just y inverse only. What about x square inverse? It will be x inverse the whole square. Now we will substitute these elements in the left hand side by the elements in the right hand side. So we will have z inverse is equal to y power 2 inverse will be y inverse the whole square. X power 4 inverse will be x inverse the whole power 4. Then y inverse will be as it is, so we are not changing it. What about x square inverse? It will be x inverse the whole square. Now we know x power 5 is equal to identity element E. X inverse can be taken as x power 4. How did we arrive at this? We can write x power 5 as x into x power 4. We will bring x to this side. So when you bring it to the other side, it becomes x inverse. So we are equating x inverse to x power 4. We have to substitute x inverse by x power 4. Similarly, we have y power 3 is equal to identity element. So what will be y inverse? It will be y square because y cube can be written as y into y square. When you bring y to the other side, this becomes y inverse. This is how we are making use of this particular expression to find out x inverse and y inverse values. So we have to substitute y inverse by y square. Now what is y inverse? It is y square. The outer power will stay as it is. What about x inverse? It is x power 4. The outer power will stay as it is. What about y inverse? This is nothing but just y inverse. So y inverse is y square now. Then what about x inverse? It is x power 4. So we are having the outer power as it is. Now just multiply the powers. 2 2s are 4. So this will be y power 4. Then 4 into 4 will be 16. So it is x power 16. Then we have y square. Then we have 4 into 2 as 8. So this will be x power 8. This will be the z inverse so far. Now we know x power 5 is equal to identity element and y cube is equal to identity element. We will reduce the power of x modulo 5 and the power of y modulo 3. We will work it out separately and then apply in this particular space. Let's take y power 4. When you are applying y power 4 mod 3, because for y we have y power 3, so we have to go for power of y modulo 3. When we have y 4 mod 3, what will be the value? We will have only y. So when you divide 4 by 3, the remainder is 1. So you are going with y power 1, which is y. What about x power 16? You have to use modulo 5 here to the power. So x 16 mod 5. 5 3s are 15. So you will have only x power 1. So we are taking it as x. What about y square? What is y power 2 mod 3? It is y square again, because 2 is not divisible by 3. What about x power 8? We have x power 8 mod 5. 5 ones are 5. 8 minus 5 will give 3 as the remainder. So we have x cube here. Now instead of y power 4, we have y here. Instead of x power 16, we have x here. Y square is not getting changed, so we are keeping it as it is. What about x power 8? It is x power 3 now. This will be the inverse of z. Where do we find the value matching? In option number 2. Option 2 will be the right answer. Next question. Which one of the following is not a basic solution of system of linear equation? So we are given 2 equations. Out of these 4 options, 3 options are basic solutions. 1 option is not a basic solution. What is a basic solution? A basic solution is obtained by setting some variables to 0 and solve for the remaining variables. So let's take the 2 equations. x1 plus 2x2 plus x3 is equal to 4. 2x1 plus x2 plus 5x3 is equal to 5. First we will set one variable to 0 and solve for the other 2 variables to get the basic solution. First let's take x3 as 0. What will be the first equation? x1 plus 2x2 is equal to 4. What about the second equation? 2x1 plus x2 is equal to 5. So these 2 equations has to be solved first. We can multiply this equation by 2. This will be 2x1 plus 4x2 is equal to 8. Then we have 2x1 plus x2 is equal to 5. We have to subtract these equations. We will cancel these 2 terms. 4 minus 1 will give 3x2. 8 minus 5 will give 3. What is the value of x2? It is 1. What about x1 from this? We will take the first equation. x1 plus 2 into 1 is equal to 4. x1 is equal to 4 minus 2. So x1 is equal to 2. We have x1 is equal to 2 and x2 is equal to 1 from this particular set of equation. 2 and 1 are there as solution in option 2. So this is definitely a basic solution. What about the next case? We have to set x2 to 0. So let's have x1 plus x3 is equal to 4. 2x1 plus 5x3 is equal to 5. We have to solve for these 2 equations now. We can again multiply this by 2. Then we have 2x1 plus 5x3 which is equal to 5. So when you subtract, you can cancel x1 here. What about 2 minus 5? It is minus 3x3 equal to 8 minus 5 is 3. From this we get the value x3 is equal to minus 1. Now substitute x1 minus 1 is equal to 4. Then we have x1 is equal to 4 plus 1. So x1 is equal to 5. We have x1 is equal to 5 and x3 is equal to minus 1. 5 and minus 1 are available in option 3. This is also a basic solution. What about the third case? We have to set x1 to 0. So this will be 2x2 plus x3 which is equal to 4. Then x2 plus 5x3 which is equal to 5. Let's solve for these 2 equations. We can multiply this second equation by 2. So this will stay as it is. 2x2 plus x3 is equal to 4. 2 into x2 plus 2 into 5 will give 10x3, which is equal to 2 into 5 will give 10 here. Just go for subtraction. X2 will go. 1 minus 10 will be minus 9x3, which is equal to 4 minus 10 will be minus 6. Minus and minus will get cancelled. X3 is equal to 6 by 9. When you cancel by 3, you have 3 into 2 as 6 and 3 into 3 as 9. So x3 will have a value of 2 by 3. Now we will substitute in 2x2 plus 2 by 3 is equal to 4. 2x2 will be 4 minus 2 by 3. When you take LCM, it is 4 into 3 is 12. 12 minus 2 by 3, which will give 10 by 3. Now x2 will be 10 by 3 divided by 2 here. So this will go to the denominator. So this is divided by 2. 2 and 10 will get cancelled for 5. So x2 will be having the value of 5 by 3. x2 is equal to 5 by 3 and x3 is equal to 2 by 3. We are having this basic solution in option 4. What is the left out answer here? Option 1. So option 1 will not be the basic solution of the given system of linear equation. For basic solution, you have to set one variable to 0 and then solve for the other variables. When they have given all the three variables together, even without computing for all these three cases, you can just say that this is not a basic solution based on the number of variables present. Next question. Arrange the following graph on the basis of number of edges in increasing order. They have given n greater than 3. N is nothing but the number of vertices. Kn complete graph. The number of edges of Kn will be n into n minus 1 by 2. This is option A. This is option B. This is C. This is D and this is E. What about cycle graph? It is just n. What about wheel graph? 2 into n minus 1. What about complete bipartite graphs? Actually, when you have bipartite graph as k of m comma n, the number of edges will be m into n. Since they have given n comma n, we are just going with n into n and making it as n square here. What about qn, n cubes graph? It will be n into 2 power n minus 1. We will substitute some values and see. For n is equal to 4. 4 into 4 minus 1 is 3. 4 into 3 is 12. 12 divided by 2 will give you 6. Then n is equal to 4 is given as it is. 2 into 4 minus 1 is 3, which will give you 6. N square is 4 square, it is 16. Then we have 2 power n minus 1 is 2 power 3, 8. 8 into 4 will give you 32. Similarly, for n is equal to 5, we are having 10 edges in A, 5 edges in B, 8 edges in C, 25 edges in D and 80 edges in E. You can calculate and see. I have already computed it and then given you here. When n is equal to 6, A has 15 edges, B has 6 edges, C has 10 edges, D has 36 edges and E has 192 edges. From here what you can understand is B will be having the least number of edges. We have to arrange it in increasing order, means ascending order. So B has the least number of edges because it is just having n edges. After B, you have a tight competition between A and C. So here it is 6 and 6, here it is 10 and 8, here it is 15 and 10. On the whole, wheel graph is having less number of edges compared to complete graph. So we are going with C, then A. What about D and E? 16, 32, 25, 80, 36, 192. So D followed by E. This will be the right order. Do we have any option with this sequence? No. That's why this question is dropped. Earlier they have given B, A, C, D as the answer. Just based on n is equal to 4, they might have given option 2. But they have given the condition here as n is greater than 3. It means not only for 4, anything above 3 it should apply. So just taking 4, you can say it can be BCA or BAC. But when you go for n is equal to 5 and 6, you should automatically get this order between A and C. Next question. A linear programming problem is as follows. Minimization problem is given here. Minimize z is equal to 30x minus 18y subject to the constraints 3x plus 4y less than or equal to 60, 5x minus 3y greater than or equal to 20 and x comma y is greater than or equal to 0. In this feasible region, the solution of LPP is or are. So either one option can be the solution or two option can be the solution. So we have to check whether A is a solution or not. If A is definitely a solution, then we can mark A and C only without checking C as per this question. So let's learn how to do it. Let's substitute the points into the constraints to see which ones satisfy all conditions. Let's take the points in A, B, C, D and E. Let's take 4, 0, 3 into 4 plus 4 into 0. This will be 3 into 4 is 12 plus 0 is 12. 12 is less than or equal to 60. What about 5x? It is 5 into 4 minus 3 into 0. 5 into 4 is 20. 20 is greater than or equal to 20. So both the constraints are done. Is x greater than or equal to 0? Yes, it is greater than or equal to 0. Y is equal to 0, so this is also satisfied. All the constraints are satisfied here, so this can be picked up for the solution. What about 2, 0? 3 into 2 plus 0, so 6 is less than or equal to 60 is fine. What about 5x? It is 5 into 2 minus 0, which will give you 10 greater than or equal to 20. Is it right? No. This constraint is failing here. X is of course greater than 0 and y is of course greater than 0. But this constraint is getting failed here. So this cannot be taken to the next level. What about 7, 5? 3 into 7 plus 4 into 5. 21 plus 20 will give 41. 41 is less than or equal to 60. Yes, it is right. What about next constraint? 5 into 7 minus 3 into 5. 35 minus 15 will give you 20. 20 is equal to 20 here. So definitely this is also fine. X is 7 and y is 5. Both are greater than 0. So this can also be considered. So if you take the option, this is A, B, C, D, E. What about 0, 15? This will be 0 plus 4 into 15. This will be 60 equal to 60. So this is satisfying because we have less than or equal to here. What about 0 minus 3 into 15? This will be minus 45 greater than or equal to 20. Here the condition is failing. So from here itself we can move away. What about 8, 5? We have 3 into 8 plus 4 into 5. 24 plus 20 will give 44 less than or equal to 60. So this is fine. What about 5 into 8 minus 3 into 5? 40 minus 15 will give 25. Is 25 greater than or equal to 20? Yes. X and y are also greater than 0 only. So this point can also be taken for solution consideration. They are asking for the solution of LPP. So we have picked up A, C, E. What we have to do to find the solution is we have to apply it in z is equal to 30x minus 18y. Whichever value is minimum, that value will be the solution. So minimization problem means you have to choose the minimum value. So let's check now. Z is equal to 30 into 4 minus 0. This will give a value of 120. So let's have 120 here. What about 7, 5? 30 into 7 minus 18 into 5. So this will be 210 minus 90. This will give you 120 as the difference. What about 8, 5? 30 into 8 minus 18 into 5. 30 into 8 will be 240 minus 90. What is 240 minus 90? It is 150. If they would have asked you for maximization, 150 should have been chosen. But since they have asked minimization, these two values will be taken as the solution. So which two points are the solution of this particular LPP? A and C. Option number 1, A and C only will be the right answer. So without getting into graphical method or simplex method, you can solve this problem in this way. Why shouldn't we take all the points into z is equal to 30x minus 18y directly? Just substitute 2, 0 in this minimization function. 30 into 2 will give you 60. Comparing 60 and 120, you have 60 to be the minimum value. So definitely you have to pick B as the solution. But does B satisfy both the constraint? No. Instead of finding Z value and then checking whether the constraints are fine or not, you can first check whether the points are satisfying both the constraints. Those points alone you can substitute in objective function. Next question. Which of the following statements are true about the sets? 0 belongs to empty set. Empty set representation is phi symbol. A is false because the empty set contains no element. They are asking which are true. Whichever options involve A can be ruled out, and from here itself you can find option 4, C and E only will be the right answer. Let's check for the other options. Empty set belongs to set with element 0. This is also false. The set 0 contains a single element which is 0. But here they say it's an empty set. It has no element and it has one element, that is 0. So it is false. What about C? Empty set belongs to set with empty set. This is true. The empty set is an element of the set. So inside this we have one element in the RHS. What is that element? It is phi. What is phi? It is empty set. Is it the same as LHS? Yes. This particular set with an empty set is a set that contains one element, which is the empty set itself. So they are equating this empty set belongs to this particular set, which is perfectly true. So C is true. What about D? Actually, both the LHS and RHS are equal here. We cannot say they belong to. It is false. Set with empty set is not an element of set with empty set. Instead, it is equal. This is a set and inside that you have empty set. This is what is present in both LHS and RHS. It can be denoted by equal to symbol and not belong to. When do we use actually belong to? Belong to means we can say this element belongs to a particular set, or we can say this element is member of a particular set. What about E? This symbol is actually proper subset. Say for example, if we have 1, 2 here and we have only 1, this will be the proper subset. This element can be one of the elements in RHS, but it should not be equal to RHS. Now just take E. This set is a proper subset of this particular set. The set contains only one element, which is the empty set. This is with respect to LHS. What about RHS? The set empty set, comma, set with empty set contains two elements. This is one element, this is one element. The empty set and the set with empty set. So this is definitely a proper subset. Next question. Match the list 1 with list 2. Match the logical equivalence propositions. There is a series in this channel, CS Connect series. Under that, mathematical logic playlist is there. If you go to propositional equivalences video, you can watch that video for elaborate explanation of propositional equivalences. In list 1, let's go for A. We have P implies Q. We know P implies Q is equivalent to negation of P or Q. This is one of the propositional equivalence law that we know. So based on that, we are mapping A to 2. A2 is available in 2 of the options. Next, we have one more law with regard to by implication operation. P by implies Q will be equivalent to P and Q or negation of P and negation of Q. This is also listed in one of the laws in prepositional equivalences. So C will be mapping to 1. So we have two options matching here. C is wrong here. So we will go with option 3 as the right answer. So let's start with C first. So let's take P by implies Q. What is P by implication Q? It is P implies Q and Q implies P. This is the basic law that we know. What is P implies Q? It is negation of P or Q. And what is Q implies P? It is negation of Q or P. Now we'll just try to expand this. This is negation of P, negation of Q with conjunction. So negation of P and negation of Q. Then we have disjunction here. We'll place it outside. Then we'll go with Q and negation of Q. Then we'll go with disjunction again. Then we have negation of P with P. So negation of P and P. Again we will go with disjunction. Then we have Q and P. So this will be Q and P. What is Q and negation of Q? It is actually false. What is P and negation of P? It is actually false. When you have disjunction with false, what happens? If you have P disjunction false, this will be equal to P. So taking that into account, we can forget about these two terms, and finally we will have negation of P and negation of Q, or Q and P can be written as P and Q. Now rearrange this P and Q or negation of P and negation of Q. Did we get list 2 first option here? Yes. Now let's get into B. We have negation here. P or negation of P and Q. We will apply the negation inside first. This will become negation of P. Negation of disjunction will become conjunction. Then we will apply the negation to the complete expression here. This will be negation of negation P and Q. Now negation of P and conjunction will stay as it is. Apply here negation of negation P. Negation of conjunction will give you disjunction. Then we have negation of Q. So this can be written as negation of P and P or negation of Q. So this can be negation of P and P. Take the disjunction outside. Then we go for negation of P and negation of Q. What is negation of P and P? This will be false. False disjunction, some preposition will be the preposition itself. So this will be negation of P and negation of Q. If you take the negation outside, this will be P and Q and this will turn to disjunction. This is available in 3. So B will be mapping to 3 here. If you have found the solution, what you can do is you can start with 3. This will be negation of P or Q. This can be taken as negation of P and negation of Q. So this particular expression and this particular expression are same. Let's take this to be B1 and this to be B2. B1 and B2 are same. From here also you can say B will be mapping to 3. So here it is C1. Now we will move to D expression. Negation of P by implies Q. We will use the same law here. Just have negation. Go with P implies Q and Q implies P. Apply the negation inside. This is negation of P implies Q. This negation will change conjunction to disjunction. Then negation of Q implies P. P implies Q can be negation of P or Q. Disjunction, negation of Q or P. Now we will have negation of negation P. Negation of disjunction will be conjunction and this will be negation of Q. This is one expression. Let's have disjunction as it is. Now we will have negation of negation Q and negation of P. What will this give you ultimately? Negation of negation P will be P and negation of Q, or we will have Q negation of P. This will be P disjunction Q. We will have and here, then P disjunction negation of P. We will again have and here. We have Q disjunction negation of Q or negation of Q disjunction Q. Then we have and we have negation of Q disjunction negation of P. So what is P or not P? This will give you true. Q or not Q will give you true. P and true will give you P. Taking this into consideration, we are not worried about this true in conjunction. Similar to false in disjunction, we will go with P or Q and negation of Q or negation of P. This can be otherwise written as P or Q and negation of P or negation of Q. So this can be taken as D1. Now the left out option is actually 4. Negation of P by implies Q. Basically we will write P implies Q and we have Q implies P. This is for P by implies Q. Now wherever you have P, just negate it. Here is a negation, here is a negation. What is negation of P implies Q? It is negation of negation P or Q, and we have negation of Q or negation of P. What is negation of negation P? It is P or Q and negation of Q or negation of P. Just rearrange it, P or Q and negation of P or negation of Q. This is D2. Are they equal? Yes, they are equal. So from this we can say D will be mapping to 4. So from this we can conclude option 3 will be the right answer. Just for examination point of view, work only with A and C to find the answer. To make it very short, just work with C alone. So if you find C is 1, definitely without checking A, B and D, you can conclude the answer. With this we are completing Unit 1 solutions.